Although this video is supposed to be about counting protons and neutrons, given some minor information, I thought it might be helpful to show you Table O. I typically don't show Table O until we do nuclear chemistry, which is the last unit of the year, but there's some valuable information in here that might help you out. Some of it, though, you have to kind of ignore for now. Alpha particles are not something that's really going to help you at this point. Gamma, not going to help you, and positrons, not going to help you. But if you realize that a beta particle is essentially an electron, then this may help you. So an electron has a charge, which is this lower number of -1, and the upper number, just like in the periodic table, is the mass, and it's 0. A neutron has a charge of 0, but its mass is 1. And then a proton, and the reason why you see two different notations here, P represents proton, but H is hydrogen because the number of protons actually defines the element. So anything with one proton would be hydrogen. So either of these notations we use when we talk about protons in nuclear chemistry. So if you ever need to remind yourself of the charge or the mass or the symbol you might want to use to represent any of those subatomic particles, electrons, protons, or neutrons, you can actually look in Table O. So let's take an example of an element. Let's say we had potassium 39 written like this. The K is telling us the element. The 39 is actually the mass of that isotope. Recall that elements can have different masses, but if it's the same element, it has to have the same number of protons. So when we look this up in the periodic table, you're going to find that it has an atomic number of 19. That 19 is the number of protons. In order to calculate the number of neutrons, since only protons and neutrons have mass, you're just going to find the difference between the two. So we take our mass of 39 and subtract the 19 protons, and you will find that you have 20 neutrons. So the atomic mass is always protons plus neutrons. You can calculate the number of neutrons by subtracting the number of protons or the atomic number from the mass you're given.